Hello, my name is Kainton, and today I'm going to give you a simple explanation of insertion sort algorithm if you are taking computer science or you simply by curiosity want to understand this sorting algorithm. This will be very good for you. So the best thing to do is to simply take an example and run through the procedure and see how it works. So this is our starting point. Well, before I continue, let me remind you to subscribe to my channel. So click on the subscribe button below so that at least you get notified when I make new lessons. Also, feel free to leave a comment. Is there any certain algorithm you want me to explain or any other topic in computer science you would like me to explain? Now let me know in the comment below. Alright, so let's see how it works. But before I continue, I'd like to explain to you why this is called insertion sort. It's called insertion sort because in each iteration it actually inserts the element, a particular element in the right position. So it starts from the first two and then takes the next two. At each point it chooses a key. The key is the element that is not placed correctly, right? The key is the element that is not placed correctly, and then it inserts it in the right position. So let me make it clear to you. So now this is what this algorithm does, something called pairwise swapping. So in case of pairwise swapping, it compares two elements, right, like 5 and 2, and the key is the one that is not correctly placed. So the key has to be moved to the right position. Alright, so let's start. Let's take this first two, 5 and 2. So what is the key? The key is 2. And what happens? It has to move 2 to the right position. So when we compare 5 and 2, 2 is lesser, and then we need to move 2 to 5 and 5 to 2. Meanwhile, let me tell you that we want to sort this array in non-decreasing order. Well, you can call it as ascending order, but the best way to call it is non-decreasing order, meaning that the smallest element has to come first and gradually it goes to the bigger element. So in this case, our key in step 1, our key is what? Our key is 2, right? Fine. So in the first iteration, let's now draw the table to see what it's going to look like when the first iteration completes. So at this point we have this. So here you have, we need to swap 5 and 2, meaning that we actually insert 2 in the right position. So in this case we have 2 and we have 5. Then other ones remains the way they are, 1, 3. So this is step 1. Let's call it S1. Now in the next iteration we are going to compare these two, and when we compare it, 4 is actually less than 5, meaning that we are going to swap. So let's draw the table to see exactly what it is going to look like. So in the next step we are going to swap 5 and 4, meaning that we have 2, 4. We insert 4 in the right position, that is position after 2, and now we have 5, we have 6, we have 1, 3. I think this is making some sense. So if it doesn't, leave a comment to let me know if you need me to explain a little more. So let's see what happens in the next step. The next step, note that in step 2 we also have a key. And what is our key? Our key is 4, because this is what we are going to move. So in this case we have 2, 4 is okay, 4, 5 is okay, 5, 6 is okay because we are taking it in pairs. 2, 4, 4, 5, 5, 6. Now we have 1, 6. This is our key. because 6 is less, and we need to move 1 is less than 6, meaning that we need to move 1 to the right position. So this is where it gets a little tricky. When it comes to this case, you don't actually leave the preceding elements in place. You actually move this one in several steps. So the first thing, you move it. Since this key stays in a temporary memory, we actually will compare it with 6. We find out it is less than 6. Compare it with 5. It is less than 5. Compare with 4. It's less. Compare with 2. It is less. So we insert it here. So in this case, you can see that the name is actually insertion sort. It's different from bubble sort that will actually swap and actually leave every other thing in place. But in this case, we have insertion sort. In another the video, I'm going to explain bubble sort to you. So when we place 1 here, we shift every other thing, right? So this time we are shifting 4, 5, 4, 5 is going 2, 4, 5, right? When we put 1 here, 2, 4, 5 is going to shift. So we have 2, we have 4, we have 5, right? So and you also have 6 is going to shift to this position, and now we have 3. I hope this is becoming a little clear to you. So this is our step 3, and here we have in step 2 we have key of what? Key of 4. In step 3 we use a key of 1. Now we are going to choose a key to use for this step. So what key are we going to use? Now we have 1, 2 is okay, 2, 4 is okay, 4, 5 is okay, 5, 6 is okay, and 6, 3. We have 6, 3. So it means that we have a problem with 6, 3. So we are going to move 3 to the right position. Already you know that we need to move it all the way to insert it in the right place in the array. So of course this is our key. So at this point, let's redraw the table this way. So when we move 3 to 6, compare it, no, it's less. Move it to this place, compare it is less. Move it to this place, is less. Right? So we move, compare with 2, we find out that it is greater than 2, meaning that we are going to insert it just after 2. So we have 1, 2, they remain in place. So we are going to insert it in place of 4, because already you know it's insertion sort. So at this point when we need to insert 3, not 4. So let me take back my pen. So I insert 3 here. Of course, it's insertion sort, S4. So now when we insert 3, we move everything by shifting. We always perform a shift. Don't forget, we need to perform a shift, unlike in bubble sort. That is actually the difference between this and bubble sort. So at this point we shift 4, 5, 6, 4, 5, 6. So let's see 1, 2, 2, 3, 3, 4, 5, 6. So at this point we have it sorted. So this is how insertion sort works, and I can also tell you the algorithm for insertion sort is super easy to understand. I'm going to show you the algorithm and then explain it to you a bit. So we have I is equal to 1. Remember, we choose 2, which is the second element at this point. We have index of 2 is 1. So we start with index of 2. So while I is less than the length of the array, so we are moving from the second element to the length of the array, right? Okay. So while j is greater than 0, so we have an index that is counting backwards from the key backwards as we compare back to position 0, and AJI is greater than AI. So when the element being compared is greater than the element in place. So what you do, you swap AJ and AIJ all the way until the end. So you continue to do this until I is equal to you increment I, okay, this while loop, and until you complete traversing the whole array. So this is actually an algorithm. If you'd like me to show you through the program, just leave a comment, let me know what programming language you want me to implement this in, and I'll actually take you through a lesson of writing this program and running it. So this is how insertion sort works. Remember, it does pairwise swapping, and it also always chooses a key at a particular time. I remain Kindton the Genius. Remember to subscribe. Click on subscribe button down there, and also like this video, share it with your friends if it's been informative for you. I'd like to thank you for viewing.